covering over 348,000 square kilometers and containing more than 3,000 reefs and 900 islands, the Great Barrier Reef is the largest living structure on Earth and one of the most important biological systems in the world. Not only does it protect the Australian coastlines and the animals that live there from tropical storms and swells, but it also provides over $4.8 billion of fishing and tourism revenue to Australia and almost 64,000 jobs. It harbors tens of thousands of diverse and unique species that intertwine to form a complex and beautiful ecosystem. Because of this importance, the Great Barrier Reef is one of the most protected and cared for reefs on planet Earth. In 2016 alone, the Australian government pledged to give $377 million to protect the reef, adding on to the $1.5 billion already being donated over the next decade. Even with all this protection, however, the corals in the Great Barrier Reef are still suffering. During the summer of 2016, the once vibrant and colorful corals, beaming with life, decayed into a ghostly white graveyard that extended for miles. This heart-wrenching sight that was once very rare has now become commonplace because of the warming climate. Research has shown that in order to save the coral and the habitats that they provide, humans will have to cut and remove massive amounts of CO2 from both the ocean and atmosphere alike. In the meantime, however, many scientists are finding new ways to help the coral adapt and thrive in this changing environment. Although coral bleaching does not directly affect us, the fallout that would happen if all or most of the coral dies would be unimaginably severe and cause massive problems all over the world. In order to understand why and how these corals are dying and what we can do to save them, we have to get a basic understanding of what corals are and how they help the oceans. Corals, unlike what most people think, are made up of hundreds of thousands of small animals called polyps. These polyps come together and work communally to form hard exoskeletons of calcium carbonate to protect them from predators. These structures, as well as the exoskeletons of old corals, provide the foundation for life of over a quarter of all the biodiversity in the ocean. Because corals can't move too far out of their exoskeletons, they rely on small algae communities called zooxanthellae that live on their mouths. These two organisms form a symbiotic relationship where the coral protects the zooxanthellae from attack, and the zooxanthellae provide the coral with nutrients and energy. Zooxanthellae, like many other plants, get their nutrients by using photosynthesis to transfer light energy into cellular energy, and they pass this along to the coral. They also provide the beautiful color and vibrancy that you see when you look at coral. However, zooxanthellae can only grow and produce at certain temperatures. When they start failing to produce nutrients, the corals expel them to make room for more efficient and better producing algae. But because most, if not all, the algae that corals can house die in this hot water, the corals turn white and begin to starve. If the water temperature doesn't cool down fast enough, the corals can starve to death and destroy the habitats of the many animals that live within them. This rise in global ocean temperature is one of the many devastating side effects of climate change. Because of rising CO2 levels in the atmosphere, the oceans are rapidly heating up and becoming filled with carbon dioxide. This accelerated change has massive impacts on the diverse and abundant ocean life that can't adapt quickly enough to survive. And these changes are not a part of the Earth's natural process. Instead, they're a result of human activities and actions. In a report by NASA, they found that 97% or more of actively publishing climate scientists agree that climate warming trends over the past century are extremely likely due to human activities. This means that it is our job to combat these changes and mend our mistakes so that the world will stay beautiful and diverse for generations to come. This change will take massive amounts of effort and money and won't come without sacrifices. So far, the Earth's global temperature has increased 1.62 degrees Fahrenheit, with most of the warming happening in the last 35 years. This trend keeps getting worse, with 5 of the warmest years on record happening after 2010. In the ocean specifically, the temperature has risen 0.4 degrees Fahrenheit, and the surface acidity has increased 30% since the Industrial Revolution, with the amount of carbon dioxide being absorbed by the upper layer of the oceans increasing by 2 billion tons per year. Although some of these changes may sound like small amounts with little to no impact on our lives, the Earth's temperature has remained very stable and consistent over its lifespan with little to no big changes. To put some of these numbers in perspective, at the end of the last ice age, when the northeast United States was covered by more than 3,000 feet of ice, average temperatures were only 5 to 9 degrees cooler than today. These changes need to be stopped as quickly as possible to keep temperatures from spiraling out of control, because as the temperature increases, the rate at which Earth gets hotter also increases. Although corals have survived over 15,000 years with 4 glacier and interglacial cycles, those changes have been slow and deliberate, allowing the coral and other animals to adapt and thrive in the changing conditions. However, with man-made technologies, this global climate change is happening so rapidly that the corals can't adapt fast enough. They are being killed off with less and less time to recover. For bleaching to occur, it only takes a sustained 1 degree Celsius spike in water temperature. And in 2015 and 2016, sea surface temperatures rose by more than 2 degrees Celsius for over a month. Many corals are able to survive these types of bleaching events, but they become extremely weak and sensitive. Scientists have stated that it takes over a decade for corals to fully recover, and after the last major bleaching event in 2016, there have been countless other minor bleaching events that have prevented the corals from recovering. Scientists believe that this negative cycle will only get worse and predict that almost 90% of all the coral in the oceans will be dead by 2050. Jennifer Koss, the National Oceanic and Atmospheric Administration's Coral Reef Conservation Program Director, pointed out at a recent press conference,
"If you think of corals as canaries in a coal mine, they're chirping really loud right now. That is, the ones that are still alive."
Not only does this terrible phenomena destroy corals and the amazing beauty that live within them, but it also kills other animals and organisms that rely on corals to survive. This type of relationship extends to a plethora of other animals and extends all the way to humans who rely on fishing for food and jobs to survive. This is why many scientists call the coral the rainforests of the sea. For example, the clownfish, which usually lives within sea anemones, a type of coral without a hard skeleton, will begin to change its body and expend more energy if the coral it lives in begins bleaching, causing the clownfish to be weaker and more susceptible to threats, putting them on the track to extinction. These problems are especially important in the Great Barrier Reef because so many people and animals rely on the coral to survive. Not only does it provide habitats for many fish and animals in the reefs, but it helps protect Australia from rough storms and swells. Without the coral, many more storms and flooding would occur on the coast of Australia, causing massive amounts of damage and hardship for the people and animals that live there. Around the world, these problems are causing huge losses both economically and environmentally, with as much as $375 billion lost annually. Over the past 2 years, around 30% of the coral in the Great Barrier Reef and over 67% of the northern region, around the size of Washington, D.C. to Maine, experience bleaching. Even with all the environmental protection allocated to the Great Barrier Reef, these problems are still getting worse and can only be prevented with a global response. There are still many protection measures that Australia and Queensland have taken to help increase the coral viability. These include improving water quality, decreasing port and coastal development, and decreasing overfishing and illegal activities. Many of the sponsored projects happening in Australia and Queensland are focused on improving farming and water quality, such as the Burdekin nitrogen trials, the Wet Tropics Major Integrated Project, and the Smart Cane BMP project. All of these projects have helped decrease runoff to local waterways while helping to decrease the amount of nutrient, pesticide, and nitrogen losses. Specifically on the Great Barrier Reef, there are many rangers doing all that they can to help. They deliver essential services all across the Great Expanse to protect the marine life, such as monitoring turtle and seabird breeding islands, removing pests, surveying vulnerable species, responding to environmental threat incidents, and conducting controlled burns to prevent wildfires. The rangers also do all that they can to help tourists and visitors have amazing trips there, from developing walking tracks and camping areas to conducting compliance activities and making sure visitors are welcomed and taken care of. The government of Queensland also has many other projects, such as creating net-free fishing zones and protecting wetlands and many other areas under the Queensland Reef Water Quality Program. The biggest project they are supporting is to limit the impacts of port operations and expansions, including dredging. First, the government prohibited sea-based disposal of capital dredge material within the Great Barrier Reef World Heritage Area and restricted new port development to within current port limits and outside Commonwealth and state marine parks. They also prohibited major capital dredging for the development of new or expansion of existing port facilities outside of the 4 priority ports at Gladstone, Abbott Point, Townsville, and Hayple. They also introduced the maintenance dredging strategy for Great Barrier Reef World Heritage Area to improve consultation, management, and monitoring relating to maintenance dredging. All of these responses do have an impact, and they help reduce the amount of stresses corals are under, helping them to recover after major bleaching events. Many other countries need to follow the footsteps of Australia and Queensland and put in place many of the legislation that is already in place there. Even though the main response to coral bleaching would be to cut global carbon emissions and begin to remove the CO2 that's in the air and oceans, many governments and corporations don't care enough to spend the time and money to do so. Therefore, many scientists are preparing for human intervention. David Suggett, a marine biologist who leads the Future Reefs program of the University of Technology, Sydney, talked about this dilemma in an interview.
What we're trying to do with this work is to understand what would happen in a situation where we had to rely on human intervention in order to keep reefs viable. That's not what we want, of course. Plan A is to reduce emissions, solve climate change, and take away the threat to reefs. But we have to prepare for the possibility of Plan F, dealing with global reef meltdown. Everyone's wary about the intervention, and rightly so, because the larger the scale of reef restoration, the larger the ecological ripple effects. Let's hope we don't need to go there, but let's understand the science in case we do.
Over the past 20 years, the Great Barrier Reef and the Australian government have been very stringent on preventing human intervention in the reef. Following a report published by the U.S. National Academies of Science, Engineering, and Medicine, or NAS, that stated human intervention is needed to ensure the persistence of the world's coral reefs, which are of incalculable value to human well-being, national economies, and future wonder, the Great Barrier Reef and Australian government have reconsidered their previous stance and are focusing on a more direct approach to fighting climate change's effects. As Stanford biologist Stephen Palumbi, who chaired the NAS committee and is also a member of the National Geographic Society's Executive Committee, says,
"The Coral Report is a pragmatic list of tools for helping reefs survive climate change, kind of like what always happens when the panic of a crisis ebbs and you have to get down to the solutions."
Some of these solutions include moving more resistant corals, such as the ones that can live near volcanic vents, submarine springs, shallow waters, or in the Persian Gulf where temperatures are constantly above 95 degrees Fahrenheit, to the most affected areas. But first, the world needs to be aware of what is happening to the coral reefs. Richard Vevers, the founder and CEO of the Ocean Agency and 50 Reef team, partnered with Google to take pictures of coral in over 50 different reefs. These pictures are able to be used for scientific research as well as be on the open web for anyone to view and take a virtual dive. Vevers also created an algorithm that can analyze the pictures of the reefs in hours instead of the years that it used to take before. Additionally, Vevers is showing these pictures to local communities to gain their support in helping the reefs. Since many of the people in these communities don't understand how the corals affect their day-to-day life, being able to show them pictures of these beautiful animals gives them something to support. By getting their support and hopefully the support of the general population, we can start putting pressure on governments to enact change and help save corals. Dr. Ruth Gates, a director at the Hawaii Institute of Marine Biology, is doing just that by breeding supercorals. Her lab goes out into extreme ocean environments and identifies the strongest corals and trains them back in the lab. When the corals become mature, she breeds the corals together to create even stronger baby corals. This process is called assisted evolution because it involves the process of natural selection, but with the added benefit of human intervention. After these corals have been bred, the best ones are placed where the reefs have been badly damaged. This helps the corals recover and gain support when the time in between bleaching events is too fast for them to recover on their own. All of these advances will help corals tremendously, but if the technique isn't scalable, these measures wouldn't be practical on a global scale. This is why Dr. Dirk Peterson, the founder and executive director of Seacor, is researching new ways to spread the supercorals. After the team brings the corals back to the lab and breeds them, they put the larvae in tetrapod substrates and easily place them all over the reef. Because of how easy and cheap these tetrapods are to create, this will make spreading the supercorals viable on a global scale. As Seacor's research director, Dr. Margaret Miller says,
Sewing the same number of corals could be achieved in less than 50 person-hours, a time saving of over 90%. Additionally, material costs could be reduced up to 1/3, representing a substantial advance for future restoration work.
there is still a lot of work to be done, and the problem is unfortunately still getting worse. But there are people making steps in the right direction to help corals survive in this new changing. Now, many of the responses I mentioned to coral bleaching seem to be focused on experts making changes and discoveries, and that this problem is way too big to be solved by people like you. But there are many steps that you can take to help the corals. First, you need to make sure to recycle and dispose of trash properly. The debris from stray or improper packaging of trash can find a way to the oceans and be extremely harmful to coral. Second, if you use fertilizers for work or for your house, you should research which fertilizers are most economically friendly and which ones require the least amount of fertilizer. Doing this, as well as trying to reduce your stormwater runoff by installing catchments and rain gardens, will help protect pollutants from finding their way to the ocean where they can harm and prevent coral reefs from growing. If you're traveling around a city, try to use environmentally friendly modes of transportation, such as walking, biking, or public transport, as well as doing your best to save energy by turning off lights and electronic devices when they are not in use and buying energy-efficient appliances. These methods will help reduce your carbon footprint and help protect the corals from more CO2 in the air and waters. If you are buying any aquarium fish, please be conscious of where and what you are buying, and try to avoid purchasing live coral and make sure all the fish have been collected in a sustainable manner. The key to helping coral, however, is to spread the word. This is a global issue that requires a global response. So do your best to spread the word, whether that be by sharing this podcast, doing your own research and sharing that information with your peers, or contacting your local representative to see what your government is doing to protect the reefs. Because the word needs to get out to help protect these corals from further damage in the future and save their amazing beauty for generations to come. Thank you. And a special thank you to Sun, Mary Kate, Scott, and Violet for doing the voice recordings.